Now, when we talk about this growing stock, this is what this FSI is doing. Now, when we measure or when we calculate the estimate the growing stock, we need field information, because until and unless you have a field measurement, you can't do any modeling. Yesterday, I think Professor Joshi has mentioned, without sensing, remote sensing has no sense. Means, if until and unless you sense on the ground, that is ground truth, if you do, remote sensing can give you any accurate information. Sorry. So we need to do the actual ground measurement, particularly for this type of estimates. When we are talking about growing stock and any other estimates, this has to be substantiated by the ground measurement first. So that is what, without the detailed measurement, we can't understand the potential of growth contained within a single tree species or even a population. So even when we see that, this is one example. As per standards, as per normally growing stock is being estimated by all the state forest departments for as a requirement for forest working plans. Earlier, as per working plan codes, there is a requirement of at least 10% sampling intensity. So when we talk about sampling intensity means out of total area which is to be estimated, which is to be calculated, growing stock calculated, at least 10% of the area to be ground survey. So here is one example. These are the division 100 compartments are there. Even if we make a 5% or 10% sampling intensity, even if you see, some of the compartments will be untouched. And these all hundreds are based on the variability. There is a differences in the growing stock. That means when we do normal field survey, there is always likelihood that we will be either overestimating or will be underestimating. To make a very reasonable, accurate estimations only by ground survey, we have to do the total survey. So that is 100% sampling. So if we do the 100% sampling, there is no use of other technology, and it will be very costly. It will be time consuming, and it is not necessary at all, because when higher technologies are available. So what we normally do here is that statistically what we do is that, for this we need to first understand what is the sample size required. It's not the sampling intensity, sample size. To calculate the sample size, all these forests which is normally a biological, when we talk about a biological population, they are always heterogeneous. So we need to subgroup those heterogeneous group is into small homogeneous group. Means we are making within the total forest area, we will be making some small groups which are relatively homogeneous. That is we call as a strata. So that will help us to first segregate this group, and then if we do the sampling in the individual all the small homogeneous group, or otherwise in the strata, then our accuracy within the strata will be very high. And summation of all the total information together will give the total estimation of the entire area. So that is how the basic concept is, that how the remote sensing geospatial technology is used in calculating the growing stock. So why it is doing this sampling is done is that to increase the precision of sample estimates. This is how this our stratification is done. Then also it helps in understanding the population variability within the population. Then reduce the sampling variance by dividing the population into number of homogeneous groups, what I have just said. And then we can follow the standard sampling procedure, maybe randomized sampling design, or maybe stratified sampling design, whatever we do. That there is a methodology, standard methodology, we can follow any of the methodology. So this will give very high accurate estimations. What we do, conventional, that I just example I have shown is conventionally it is done a simply systematic sampling. So this is that systematic sampling suffers due to various strata and burden with intensive field, and also it will be very expensive. However, satellite data, when we use the geospatial technology, so here particularly for stratification, we use this remote sensing data. So satellite data help in primarily stratification, maybe based on forest density, type, or slope, elevation, any strata which is very unique to that particular the area under study can use like elevation, sometimes soil, sometimes maybe slope, whatever required. So that will divide this entire study area into small number of groups which are relatively homogeneous, and we can distribute the sample plots only those area, and representative of those sample points will be calculated, estimated based on the data collected from those areas. But for doing those, for stratification, we need a priori knowledge. Means we need to understand the first, we need to know what is the study area. Suppose say an example in Arunachal, if we going to do a growing stock estimation, then we need to first know what is the elevation pattern there, what is the rainfall pattern there, what is the soil type, what is the general forest type, what is the normal density. That a priori knowledge is very important. So now, based on the data, based on the in the a priori knowledge, first level information, a first level grouping we can do. This type of grouping, first level grouping can be done just based on the forest non-forest area segregation. Then within the forest, what is the dense forest, what is the low open forest. This type of first level of grouping can do, and then based on this grouping, sample points can be distributed.